let's say we wanted to integrate something like x squared over the square root of 16 minus x squared. Okay, so you can try and use substitution or integration by parts or the product rule. None of those are going to work for something like this. Okay, so anytime we have a square root with a square being subtracted from another square, that's where we're going to use sign substitution. So we're going to use like cosecant and secant when it's like a square plus a square, or like a variable squared minus another square. That's going to be a tangent substitution. I'll make videos on all of them, and this can be with respect to x, but for right now, we're going to use trig substitution when we have something divided by the square root of a constant being squared minus a variable being squared. Okay, and for us to be able to do that, we have to recall that cos squared x plus sine squared x, that's going to equal 1. So that means that sine squared x is going to be equal to 1 minus cos squared x, right? And from this, we can kind of derive that if we have the square root of, I'm actually going to write it a bit differently here. Okay, if we have the square root of a squared minus x squared, where a is just a constant, and that's what we have here, right? We're going to always set x equal to a sine theta. And this is just something that you kind of want to memorize. It comes from the Pythagorean identity. Okay, so in this case, we have 16 minus x squared, so this is 4 squared minus x squared. So that means x is going to be 4 sine theta. Okay, so we're going to set x equal to 4 sine theta. And if we do, what we're going to get is the square root of 16 minus 4 sine theta squared. Okay, and what we get now is square root of 16 minus 16 sine squared theta. And we can factor out a 16. So this is going to be the square root of 16 times 1 minus sine squared theta. Okay, and 1 minus sine squared theta, that's just cos squared theta. So this is 16 cos squared theta. And using our knowledge of radicals, if we square root a product and both of them are squares, we just take the square root of each component of the product. So it's going to be 4 cos theta. And technically it's 4 times the absolute value of cosine theta, but since we're dealing with indefinite integrals, we just assume it to be positive. Okay, so we know that this whole radical is just going to be 4 cosine theta. Okay, so that's going to be our bottom. I'm just going to rewrite this up here. So the bottom is going to be 4 cosine theta. And what is our x? Well, our x is going to be 4 sine theta. We just figured that out. And we know that our bottom here, root 16 minus x squared, that's going to be 4 cos theta. X squared is just 4 sine theta squared, right? Because we're squaring x. So this is going to be equivalent to 16 sine squared theta. And in order to finish this integral off, we have to figure out what dx is. Okay, so if we know x is 4 sine theta, dx, that's going to be 4 cosine theta d theta, right? So we set dx equal to 4 cosine theta d theta, cosine theta d theta. And just by coincidence, there's a 4 cosine theta on the top and bottom we can cross out. That's going to happen lots of times when you're integrating by trig substitution. You're going to get things that cancel on the top and the bottom, which is always nice. So what we have now is 16 sine squared theta d theta, right? And anytime we have a constant, we can just take that out. So it's going to be 16 times the indefinite integral of sine squared theta d theta. Okay, so before we plug in something in terms of x for theta, let's actually integrate this. So we can integrate sine squared theta by parts, but just for the sake of time, like it'll probably take 5 or 10 minutes to do. So I'm just going to tell you that the integral of sine squared theta, let me just try and remember here, it's going to be 1/16 times 1/2 theta minus a quarter sine 2 theta. And then we're going to get this plus c up here. Okay, so that's going to be the integral of sine squared theta. Okay. Now what we're going to want to do, let's see here. Well, sine 2 theta, that's going to be, sine of 2 theta, that's going to be 2 sine theta cos theta. So we can go 16 times 1/2 theta minus 1/4 times 2 sine theta cos theta. That's also trig identity. That's going to be 1/2 sine theta cos theta. Minus 1/2 sine theta cos theta plus c. Okay, we can factor out a 1/2 to join this 16. So basically we're just multiplying the 16 by a half. So it's going to be 8, and then the 1/2s go away. It's going to be theta minus sine theta cos theta plus c. Okay, so we got rid of the integral. We got rid of all the nasty fractions, but now we have theta. And notice when we started the integral, we started with things in terms of x. But remember, we also know that x was equal to 4 sine theta. So x was equal to 4 sine theta. Okay, and that means that sine theta is equal to x over 4. So if you can imagine, we have a triangle here. We have a triangle, and this is our theta. Sine of theta is opposite over hypotenuse. So opposite is going to be x, and hypotenuse is going to be 4. So that must mean that this adjacent side is going to be 4 squared, which is 16, minus x squared. Right, that's just our Pythagorean theorem there. Okay, so we know that sine theta is going to be x over 4. Okay, so we can plug that in there. And cos theta, that's just going to be adjacent over hypotenuse. So that's going to be adjacent, which is the square root of 16 minus x squared divided by 4. Okay, so we're going to get we're going to get, let me just rewrite this. So now that we know sine theta is going to be x over 4, cos theta is, actually I don't need to rewrite it, I'll just write it down here. So it's going to be 8, right, times, we know that theta is, well, let's actually leave theta right now. We can figure that out in a sec. Actually, no, we don't need to. Let's just figure it out right now. So sine theta is x over 4. That means theta is going to be the inverse sine of x over 4. And then we're going to be subtracting. I'm just going to move this out of the way. So we know sine theta is x over 4. And we know cos theta, that's going to be square root of 16 minus x squared over 4. So it's going to be minus sine theta, which is x over 4, times root 16 minus x squared over 4. Okay, and then we get this plus c at the end. Okay, so this is going to be, if we factor out a 1/2, actually no, let's distribute this 8 into everything. So we're going to go 8 times this, 8 times that, Actually, we already did that, so we're going to go, yeah. Let me just see. Yeah, it's hard to kind of keep track of everything here. So it's going to be 8 sine to the negative 1 of x over 4 minus x over 4 times the square root. Yeah, we did everything right. Let's just combine this here. So this is going to be, let's simplify the second part. So it's going to be the inverse sine of x over 4, right? And then we get minus x root 16 minus x squared over 16 plus c. Okay, so now let's multiply this 8 into both these terms here. It's going to be 8 sine to the negative 1 of x over 4 minus 8 over 16 is just a half, so minus a half x root 16 minus x squared plus c. Okay, so that's going to be our answer for this indefinite integral here. And we can also write like negative 1/2 x is just x over 2. So this is going to be our answer. We always need that plus c there, right, because it's an indefinite integral. And yeah, I'll be talking about cosecant, secant, and tangent substitution, but this was Sine, kind of an introduction to integration by trig substitution. Hope it was helpful. See you in the next video.